Hi guys, this is Rohit and I'm back with gradient boosting and XGBoost today. I know this names probably sound a bit confounding to you, but don't worry, I'm here and I'm going to take care of it. But first let's understand this, that these are extension of the ensembling techniques that we had understood in the last lecture. So what are the ensembling techniques? So ensembling techniques are of the two types, which is naive aggregation, which is where you have a training data set and you train multiple models on each of on all the entire data set, and then you somehow aggregate the decisions from them. And what was the other technique, which is basically called the specialist training, where you had your data set and you split that into multiple parts and you train multiple models on each of those separate parts, right? And then you combine the predictions from all of them. So these are the broad two major techniques of ensembling. The third technique was called stacking, and we have already discussed about that in the lecture. So if you are not very clear with those concepts, it would be a good idea to kind of go and revisit them before we kind of proceed here further, right? Pause this and go back and visit stacking if you are not very clear with it. But if you are clear with all the concepts that we have already taught in the last ensembling lecture, so this would be a very easy cake work for you. So don't worry, we are going to start with gradient boosting and XGBoost today. And it's basically, just keep in mind, this is an extension of the ensembling concept. The ensembling concept was this, that you had multiple models which were trained on either same data or some sample of the data. Somehow they were basically models which were trained on similar type of data, and then you somehow aggregate their intelligence into one particular model, right? That is the concept of ensembling, and that's exactly something we are going to again do today. The only thing is that is going to differ from boosting and pasting is basically how you train those models, right? Earlier when we did it for bootstrapping, pasting and all of that, what we did was we took models and trained them on a single data set, and then we finally aggregated the intelligence, right? So those models could have been decision trees, logistic regression, combination of decision tree, logistic regression. It could have been anything that we wanted, right? And there was no particular rule as to which models should be used, right? That's something we are going to improve today. So now we are going to come up with a technique, I would say, to how you train these models, right? What are the models that you should use, and is there a reasoning behind it? Is there a way you can kind of scientifically say, okay, this is the first model that I'm going to train. Now, how your second model should look like, right? How your third model should look like? Is there more theory that we can assign to it? That's something that we are going to check today, and that's all boosting is all about. So now, don't worry much. Let's get in and kind of understand it further. So the program so far, we have already gone through linear and logistic regression, we have gone through decision trees, we have gone through ensembling as well, right? So now, what exactly is boosting? So the idea of boosting is basically, can you use a weak learner and you modify it sequentially, and you then somehow combine all of this sequentially modified weak learners into a strong learner. So that's overall concept. Obviously, I'm sure you probably did not get it completely. So let me kind of explain it a bit more through an example. So the idea of boosting is this, that we have one single model, and then we basically figure out what is the data point or what are the places where it's making an error. And then you train your second model, which basically rectifies for this error made by your first model. And then you train your third model, which rectifies for error made by your second model. Let's try and understand that through a diagram. So this is your first, so you have your entire data set and you train your first model, right? And that has got some error. So what you do next is you train your next model M2. Now what M2 does, it basically corrects for the mistakes made by the model M1, right? And then you train your model M3, which basically in turn corrects the error made by M2, right? So basically all of these are weak learners by themselves, right? M1, M2, M3, all of them are weak learners by themselves. But the idea is, can you somehow combine them in an ensemble such that combining all of them you get a strong learner, right? Because as you can clearly see, M1 rectifies for error by M2, M3 rectifies error by M2, right? So if you combine such models like M1, M2, M3, you can end up with a reasonably strong model, right? Because your errors are sequentially being corrected in every step, right? So when you kind of combine all of them, you would have something that is probably very robust, right? So let's now also try and understand that through a diagram, a much more explicit diagram. But at the end of the day, let's kind of understand this concept. Boosting is basically this, where you're sequentially training models one after the other, such that your models are basically correcting for the errors made by your previous models, right? So that's all there is about boosting, right? So your model basically learning from the mistakes made by previous model and trying to rectify for that. And that's why if you start off with a lot of mistakes in the first model, that is probably very bad. It's a complete weak learner, very bad model. You start off with a lot of mistakes, but the number of mistakes kind of goes down, right, as your ensemble kind of increases in size. So by your third or fourth model, when it corrects for the mistakes made by third model, you would already have a lot of your original mistakes kind of reduced, right? Because every model in sequence is basically correcting for the errors made by the previous model. So all in all, combining all of them, you have something that is extremely strong and robust. So let's understand that also through a diagram. So yeah, this is something that I've already mentioned, that boosting, the idea is to use weak learning methods several times to get a succession of hypothesis, which is basically nothing but succession of models, each one refocused on the examples that the previous ones found difficult to and misclassified, right? That's very intrusive. Like, let's try and get a better idea. So this is the diagram. So first, don't try and look at the entire diagram. So this is how boosting works. Let's first develop the intuition. The intuition is this, just for now, look at box 1, right? So that is your first model. So it's a classification model. As you can see, there are pluses and there are minuses out here. Right, so you can see there is plus and there are minuses. So it's a classification problem. And for example, let's understand this is probably a logistic regression, right? You can kind of guess that because the decision boundary is very linear. It's a straight line, so it's probably a logistic regression. So it's a logistic regression which it separates your positive from negative classes. Now, when you train your first model, obviously you have some errors, right? You obviously cannot come up with the best possible models. So now you can see the best possible decision boundary that you could come up with looks something like this, right? So it has this 2 plus signs on the left of it and the other of the signals on the right of it, right? All the data points. Now, let's again go back to the concept of boosting. Boosting is this idea where this model has made some errors, right? Now when next model comes in, it's gonna correct for those errors, right? So now let's try and understand what happened here, right? So what happened is your logistic regression tried fitting the best possible line and then it made 3 errors, right? So these examples on the right are basically the ones that have been misclassified, right? The model is saying that everything on the left of the decision boundary is positive, everything on the right is negative. But by saying so, it's basically misclassifying this and these 3 examples, right? The 3 positive classes. So the second model, what it's gonna do is basically nothing but he's gonna say, okay, yeah, I think I know what you have done. You have basically misclassified those 3 examples. Now let me do something. Let me try and correct for that. So this model says, okay, I don't care whatever your predictions have been in the previous model. I'm gonna make sure these 3 examples that were misclassified by first model, I'm gonna rectify for that. So that's what the second model does, right? So second model makes sure that these 3 positive examples have been classified correctly. But by doing so, as you can see, so everything on the left of this decision boundary D2 is positive and everything to the right is negative, right? So everything to the left is positive, that is perfectly fine, but you clearly see there are 3 examples which have been misclassified, 3 negative examples now which have been misclassified. So there's some problem, right? So now you see that model M3 comes in and he says, okay, I think what happened here, I think your model M2 has misclassified those 3 negative examples. Now let me come and just make sure that those 3 examples are absolutely correctly classified, right? So then it comes and makes a decision boundary like this, which is like D3. And you can see these 3 negative examples now have been classified absolutely correctly. So that is the magic out here. Now each of your model is basically coming in and correcting, making sure that the errors made by your last model has been absolutely taken care of, right? So now, as you can clearly see, even your model M3 right now is not absolutely perfect, right? It is still misclassifying these examples. So the ones examples which are marked, which are circled, right? You can see this plus, and this negative example, right? So the 3 examples have still been misclassified. But the point to understand here is when you combine all of them together, model 1, model 2 and model 3, you get a decision boundary, a combined decision boundary which looks like this, which is 100% accurate. That's the magic of ensembling and that's the magic of boosting. Each of your model were weak learners, right? You can see each of those models making errors. Your first model had a decision boundary which was not good. Your second model and third model also have decision boundaries which don't look good. And obviously they are misclassifying examples. But the magic happened when you combine 3 of them. That's when you see something that you see here, right? So that's the power of boosting. And as you can see, this is a very powerful technique as compared to say bootstrap or pasting, right? Because now in bootstrap and pasting, you are just taking random samples of the data, training your multiple models on the same, right? There was a sequence to it. There was no thing that you were kind of trying to optimize. There were different models that were trained on different samples, and they were all random samples. In this case, this is a much more powerful technique. You have your model and it kind of makes error. Second model comes in and says, hey, I'm going to correct for that error. And that's why when you started off, you had probably not that much error. But when you kind of look back, 3 of them combined, you have absolutely a perfect model, right? So your first model did not have a lot of error. Your first model had a lot of error. Your second model came in and corrected for it. And by the time you have your third model, it's absolutely fantastic result. So that is what is called boosting. So now that we understand what is boosting, there are majorly 2 types of boosting that we are going to discuss in the lecture today. The first one is called AdaBoost or adaptive boosting, and the second is called gradient boosting. So now let's try and understand what each of them are.
Log on to GreyAtom's learning platform to unlock more free content. Subscribe to our channel and hit the bell icon for regular updates.